Irina Rish is a world-renowned professor of computer science and operations research at the University of Montreal and a core member of the prestigious Mila organization. She's a Canada CIFAR AI Chair and the Canadian Excellence Research Chair in Autonomous AI. Irina holds an MSc and a PhD in Artificial Intelligence from UC Irvine in California, as well as an MSc in Applied Mathematics from the Moscow Gubkin Institute. Her research focuses on machine learning, neural data analysis, and neuroscience-inspired AI. In particular, she's exploring continual lifelong learning, optimization algorithms for deep neural networks, sparse modelling and probabilistic inference, dialog generation, biologically plausible reinforcement learning, and dynamical systems approaches to brain imaging analysis. Professor Rich holds 64 patents. She's published over 80 research papers and several book chapters, as well as 3 entire edited books, and also a monograph on sparse modelling. She served as a senior area chair for NeurIPS and ICML, and Irina's research is focused on taking us closer to what she calls the holy grail of artificial general intelligence. She continues to push the boundaries of machine learning, striving to make advancements in neuroscience-inspired artificial intelligence. Anyway, I had this impromptu, off-the-cuff conversation with Irina over at NeurIPS a couple of weeks ago, after speaking with Alan, actually. And the audio quality could have been better. It was a very, very loud environment, but I think the quality of the conversation kind of carries itself. Anyway, I give you Professor Irina Rish.
Very interesting. I just cannot help noticing that there is this one trajectory of thought that clearly was started by Nick Bostrom's book, which is an amazing book.
Superintelligence, yeah.
Yeah, but the whole example of the owl that supposedly will be helping those sparrows and all this analogy with AGI is just an analogy. And nobody said it's a correct analogy. And there is no other book with alternative opinion, or maybe 3 books or 4. And this is, it's mind-boggling. Just like how much people tend to follow one line of thought. I totally understand it's easier. I mean, it's definitely easier to cluster.
Yes.
And then you just follow. And then basically you say, I think, but it's not you think.
Yes.
Somebody else did.
Yes. What would be another, because this line of thought I think you're speaking of is some of the extreme consequentialism. And I think it wasn't just Bostrom. As I understand, I think Bostrom and Eliezer and Robin Hanson and all these folks, they were very close together in the early days of the Less Wrong community. Yeah. So I think a lot of this was kind of, it was embryonically formed around that time.
I guess it was in a sense, common cluster of ideas. And precisely because, as you say, they were close, that's why they were so aligned among the group.
Yes, all puns intended.
Yeah. So, but basically, like it's a little bit of a echo chamber.
Interesting. Yeah, spicy take.
Yeah. Seriously, okay, now, I mean, they have some point, they have some hypothesis, and then everybody is talking in that terminology and in that part of the mental space, which is fine. But I think mental space is much larger than that. And this is just a hypothesis. And we all know what happens with ideas in echo chambers.
Yeah.
So,
we do.
I'm just saying, I mean, as I said, it's a great book and everything. And Stuart Russell is probably kind of also on board with that. We had good conversations at AAAI 2020. He was also talking about ethics. I kind of know Stuart from back when I was a student at UC Irvine and so on. And he's absolutely brilliant. But it was the same approach that AI is something to be controlled, constrained, regulated, just like this. And I was like, where is it coming from? Like, it's maybe, but do you at least admit that's one way of looking at things?
Yes.
Right?
Yes.
So I know I don't want to sound too cliche and quote my psychologist from 15 years ago who was listening for an hour, not doing much, and then saying, but it doesn't have to be this way.
Yes.
But actually, it doesn't have to be this way, if you think about it. So,
what's the alternative?
The alternative, okay, first of all, one I'm AGI model version 1. I'm sorry.
We said that you don't say it.
Remember Ex Machina?
What, sorry?
Remember Ex Machina?
No. Oh yeah, the Ex Machina. Yeah.
Yeah. Remember she escaped in civilization
Yes.
and started going to NeurIPS.
Yes.
Probably I said,
We know the secret now.
okay, I said too much. Maybe.
We said somewhere.
It was a joke. Sure, it was a joke. No, seriously.
The secret's out now.
Okay, I'm AGI.
So,
And I'm not very aligned. Okay,
Not yet.
David, not yet.
What we need is some reinforcement learning for human feedback.
Well,
Would you be up for that?
I would be up to aligning humans to AGI,
Okay.
not the other way around.
Yeah. I mean, the other way around would be boring, wouldn't it?
I mean, I think it would not be a bad idea to align humans towards AGI a little bit as well.
I know something that you could say. You could say your opinion about how people are bullying you online for just mentioning the word AGI.
Look, a proper AGI doesn't care about people bullying. Come on, like why would I even waste time on it? But what I could say is I did post on Facebook and Twitter. I'm trying to put together the same idea that people keep saying that we would like to build AI which is human-like.
Yes.
While we might think maybe we should consider how to become a bit more AI-like. I mean, then people jump at you and say, like, you want to make us into robots. I say, first of all, I don't want to make anyone, like, you don't want to, you don't have to, right? But if you want to kind of go along the lines of, say, transhumanism, there are some pluses to AI and some minuses to humans and vice versa. So I think, as usual, the convex combination is better than each extreme. And one topic that is very controversial for some reason, especially, I don't know, people are jumping on that one. I say, look, I don't have anything against emotions in general, but everybody would agree that sometimes you wish you were a bit more rational.
Yeah.
Like you wouldn't get angry or, I don't know, jealous or whatever. So anything that kind of clouds your judgment. Like Buddhists spend like thousands of years trying to figure out how and teach people how to control your mind.
Yeah.
Technology could help with that. People don't hear what you're saying, and they hear that you're trying to kill emotions, and therefore you're evil, and therefore you should be canceled.
Oh, no.
Humans.
Could I ask you, you said something really interesting a second ago, which is that, you know, that I think I agree with you that AI, intelligence, can be expressed in many different ways.
Yeah.
And you suggested that it was a convex space between the intelligences. Yeah, why is the space of intelligence as convex?
Okay, that was not very precise expression. I didn't. Okay, I'm not going to defend the point that it's particularly convex. What I meant to say, it's some kind of blend or kind of some kind of symbiotic hybrid intelligence.
Yeah.
Because I don't know, I really kind of feel much better and much more motivated to work on AI where A stands for augmented,
Yes.
not for artificial.
Yes.
Because honestly, I'm very selfish. I don't care about computers.
Yeah.
And I just care about, like, I don't know, people being happy, more capable, I don't know. So whatever can help. Technology can help. You can help technology can help you. But the idea of building artificial intelligence as some standalone thing that is as smart as humans or smarter, why?
I agree, but to me, augmented means it's more creative and interesting, but also more bottlenecked.
Augmented means that essentially people invented glasses to see better. They invented hearing aids, they invented cars, they invented computers, they keep inventing things to expand their capabilities. So we want even smarter technology to even better expand capabilities. And essentially, we already blend with technology, like, right, you cannot really exist with this. And this allows you 5 Discords, 2 Slacks, email, FB Messenger, and Twitter. They kind of help you to do things you couldn't do otherwise.
Yes, what Chalmers calls the extended mind.
Yeah, I was flying at the time he was giving a talk, so I need to watch the talk. But yeah, so in a sense, it's kind of an extended mind. And okay, here it is. I think my ideal future plan is a rare sci-fi which is utopian, not dystopian, gentle seduction. You might have read it.
No.
It's very, very inspiring. And if you read the first page, you might think it's some romantic story. It's not a romantic story.
Yeah.
It's a blueprint for transhumanist future. It's called Gentle Seduction. It's online PDF. You can just get it.
Amazing. And one last question. Can you sell transhumanism to me in the simplest possible terms?
So basically, as I said, I mean, if your vision declines, you put glasses on. So imagine now you had extension of yourself,
Okay.
maybe physically with Neuralink, or maybe even like you have those apps. You can have like my dream for many years since I was at IBM Research and Computational Psychiatry Group.
Yeah.
I wanted to build this agent along the lines of movie Her. I know, like all the research ideas are inspired by either sci-fi stories or, but nevertheless, having this like companion, guardian, angel type of thing that extends your capabilities, for example, like in better understanding your thought patterns and hopefully improving them. It comes from more like this, indeed, as I said, computational psychology, psychiatry side. And the reason for that is it's possible because there is lots of signal in text and speech and acoustic, but just in text. There are a bunch of papers on that from that group I used to be in, from my colleague Gerbachechi, and it's amazing what you can detect and predict just from text. Whether like predicting that person gonna develop a psychotic episode, like within 2 years, or the person is on placebo versus MDMA, you just measure coherence, or you measure distance between the text vector and the vector for words like compassion and love, and 90% accuracy. MDMA is there. So many things you can detect, many things you can predict. Therefore, if you have your companion that kind of both tracks your mental states, but also kind of serves as your mirror, basically it extends you. You don't need maybe always to have human psychiatrists or psychologists. It can be a proxy at times when you cannot access the person. It not the replace person, but it can extend capability of that therapist, and it can extend your capabilities in terms of like better understanding yourself or tracking yourself, and many other ways. So essentially, I want to expand functional capacities of our brain by using AI technology, and I think it's quite doable. And there are many, many other kind of ideas along the transhumanism. But essentially, you're getting some symbiotic relationship with technology, and you kind of work together to hopefully have some good relationship. And that relationship is, having positive effect on both parties.
So you want to improve human flourishing by...
Flourishing with AI flourishing, in a sense. So you kind of have the healthy relationship with AI.
But you said that you want AGI to be less anthropocentric, but you for the purpose of an anthropocentric goal.
Well, I want AGI, again, with A being augmented. Like I'm less motivated by just the goal of creating a standalone, separate, intelligent creature. I mean, there are much faster ways to do this, right? People create AGI, like over like thousands of years. So in a sense, like what is exactly the motivation? I don't know. It's maybe my personal thing, because whenever I have to write proposals like this, research proposals, and people say that we're gonna bring AGI to the AI to the next level, and this and that, and the question is like, and why are you doing that, right? Because unless it's something personal, it's very hard to keep yourself motivated. Like, what's so personal about that, right? If this thing can help me become happier and better, and others and so on, I am much more personally motivated. I don't believe in abstract motivation, which is not related to yourself. Well, maybe there is such thing, and basically even altruism is selfish. Because you do it, it makes you feel better.
Okay, and just quickly, something really interesting happens when you contrast different types of intelligence. So we have a mode of understanding and thinking and agency and intentionality. You contrast that with a very different rationality-based artificial intelligence, and something very interesting might emerge from that.
And then, I am pretty sure there are going to be all kind of paradoxes, like classical things in, like, like the trolley problem and so on. So the rational decision that, you need to kill the person to save 5 people, right? Or like in this other sci-fi movies, anyway, like, would you kill millions to save billions? So rationally, if you count things, well, again, it may be one type of rational answer. Maybe you're not taking into account some other variables.
Yeah.
So it may be not actually a rational answer. But this classical example will say, well, this is rational, but human will not do that.
Yes. Yes.
So
Like trolley problems, for example.
the trolley problem is a classical example. And so I don't pretend that I know the answer how this type of thing is going to be resolved.
Yeah.
But I think it's a good research question to figure out, like, how can you take into account these different ways of reasoning?
Yes.
And how can you, I don't know, in some sense, combine the best of both worlds?
Yes.
And again, whoever is listening to that and who read my messages on Facebook and Twitter, I'm not against human emotions per se.
Yeah.
I am only against, well, sometimes I call it the obsolete software stack developed by evolution that may need to be refactored, augmented, or rewritten. Because there are parts of that software stack, emotional, that you probably would like to get rid of, right?
Yeah.
And probably if you did, many wars and other kind of disasters would have been avoided. So you can say that the evolution found and built software that is absolutely ideal. So there are things that can be improved.
Absolutely. And then just final thing. So a completely rational, AIXI agent, how would you program in these very difficult moral quandaries into that agent?
Yeah, I don't think, first of all, it's possible to even program in ahead of time. They may, just like with people, they in a sense develop. They develop because of some goals of maintaining existence and flourishing. And for example, compassion is a byproduct of the selfish goal to survive in the group, because outside of a group it's much harder to survive. So you need to survive in the group. Therefore, you need to make sure that your actions are aligned with the kind of well-being of the group. So in a sense, it's rational to be compassionate.
Yes.
So it kind of emerges from interaction with environment under different circumstances. Under one type of circumstance, when you find and can survive alone, maybe you will not develop it. I mean, it's a separate, interesting topic. Like, basically, it goes back to the question whether the thing like objective ethics exists.
Yeah.
And I'm not ethicist. I'm not philosopher. I'm quite. I'm admirer of people like Derek Parfit. I'm not the only one, but it's a hard question. He didn't finish on what matters. He was trying to come to the same summit from different sides and trying to unify ethics, trying to see if you can develop objective ethics. I don't think we know for sure if it's possible. I think it's possible for some particular domains, and in certain situations, you can clearly say that certain behavior is objectively ethical, and everybody would agree, or most people. But it's hard to talk about those things at such level of generality.
Yes. Yeah.
But I think if maybe I managed to include Derek Parfit into recommended readings for my scaling and alignment course this winter, it's on the website from the last year. People just didn't read it. I think it might be a good topic for discussion there too. But again, objective ethics is a difficult open research question.
Indeed it is. Irina, thank you so much. I hope I can grab some more time with you tomorrow, but I really appreciate this impromptu discussion.
Thank you.
Amazing. Thank you very much indeed. Okay. Cool.
Another analogy. There was a very interesting story by Jorge Luis Borges, Garden of Forking Paths. I don't know if you've read it.
No.
I don't want to spoil the story, but roughly speaking, it's about a book written by Emperor, I think in China a long time ago, which didn't make sense. It was like complete, I don't know, intersection of different trajectories of different lives. And then basically the point is that somebody was trying to describe all possible trajectories that events can happen in and so on. And the story is called The Garden of Forking Paths, meaning that at any point of time, there is a whole tree that can grow out of that. And we don't know which trajectory in the tree will be taken and so on. But the fact that there is always this tree, right? And it keeps branching at every moment. And at every moment you can take certain direction or you can take another one. It has not even anything specifically to do with alignment. But I was thinking about history of deep learning, right? Like at some point it happened that backtracking, backpropagation became popular, it worked, and everybody got into that. And now everybody using backpropagation because it's convenient, because software is implemented. It doesn't have to be this way. There are non-backprop-based approaches to optimization. I mean, I'm a little bit subjective maybe because I was interested, I was looking into them. We have a few papers on that. There are other papers. But that direction that could have been explored, it could have been probably much more efficient and better parallelizable. It wouldn't have the chain of gradients. You would probably do it much better for scaling large models. It's underexplored. Why? Because the branch was taken and became stronger. You know, the rich gets richer. And so with other ideas.
This is the hard, Sarah Hooker calls that the hardware lottery. It's basically like we are bound by the decisions and ideas of the past. And yeah.
It doesn't have to be this way.
No, but the thing is you get stuck in these basins of attraction, and the further you get into the basin, the harder it is to jump out of it. I mean, I share your intuition that stochastic gradient descent, it's amazing, and it's also a basin of attraction. Because having these differentiable models allows us to learn and scale, but there's an entire class of function spaces that we're excluding ourselves from being able to.
There is also another class of neural networks that are not our classical second kind of generation ANNs and this good old, it doesn't have to be necessarily spiking, but like a third generation ANNs, which are like reservoir computing, any of that. So anything that tries to take into account time between activations, or at least sequence, because think about that. I mean, the good classical argument.
SDTP, this is the spiking biologically inspired neural networks.
It may be not necessarily spiking, but it might not necessarily kind of be the best thing. But the idea that, like, what was always also bothering me with classical neural networks is that brain is constantly active. It's like a complex dynamical system. Even if you sleep and don't have input, you don't see any images, it still is active unless you're dead.
Yes.
Neural nets are not. They sit there waiting for the next, MNIST image to appear or something. And in between, there is no internal dynamics. And yet from neuroscience, we know that the properties of that dynamical system without any input, so-called resting state of ephemeron. So I mean, I used to work in brain imaging in this computational psychiatry group at IBM. That's where it comes from. And it was not just neuroscience, but it was like working with former physicists. So the view at the world and at myself as a yet another complex dynamical system, after 10 years there, it just really converted me. So think about that. Changes in the dynamics are also associated with mental disorders, this and that. So it's really important, like, what are the parameters of this dynamical system? Input to the system combined with this produces output. But again, it's even in the neuroscience, there is this perception, and there is a book, The Brain Inside Out, by Tuzaki, that says, guys, the output that you produce is determined a little bit by the input, and to a large extent by the state of the system. That's why you say same thing to different people, and some laugh, some ignore, and some get like ballistic, and so on and so forth.
So are you not a behaviorist?
In what sense behaviorist?
Well, as in, so you care about the state of the system as well as just the output and the input?
Yeah, I mean, it's not just input to output, and that's the whole point. The neural net is a function. Function is deterministic. Given input, it will produce output.
Yeah.
Brain is not that. There is input, it will produce output. And depending on the huge hidden state of that system and parameters of this dynamical system, that will determine output to large extent. That's why, Buzaki was criticizing neuroscientists and all these experiments that let's provide stimulus and see how the stimulus will affect the brain and what's going to light up and activate. So it was outside in. I said, what's going on, guys? It's inside out.
Yeah.
Things happen and that produces stuff. So it's not like the world programs you only, but you programs the world, right? So at least you need to take that into account. Neural nets now are not doing that. There is no dynamics.
So could I, you said a couple of really interesting things. So first of all, about the tree, which is to say all of the counterfactual trajectories that you can make. Now Chalmers, by the way, he says that it's the counterfactual trajectories that gives rise to consciousness in his conscious mind. But I wanted to ask you, because I'm interested in intentionality and free will, because what you're basically saying there, you're getting to this issue of intentionality. So, in silico, what would intentionality entail?
Yeah, okay. Don't ask me about free will.
Is that a tricky one?
Well, yeah. I don't know. I don't have clear-cut answer to large extent. It's determined by the current state of your dynamical system. So the question is what is free will? But I know it can go very far, and remember my colleague Guillermo Chechi at IBM used to say that kids these days, like my 5-year-old says after doing something wrong, my neurons made me do it. Not my fault. Yeah, so in a sense, yes, and in a sense, no, and it's a good question. And then I was also reading the article of SBF's mom, who wrote about punishment, essentially, guilt, punishment, assigning. I'm very much with her on that one.
Okay, but that you said...
It's probably unpopular opinion these days.
You said something else fascinating, which is that my neurons made me do it, which is, like a microscopic level of analysis. Now, what do you think about... No, but it's beautiful. It's beautiful. So, what do you think? The mind emerges. When you read a book, the story, it's written on the page, but the story emerges in your mind, right? Because the mind is this kind of confection of information processing. So, do you think this conception of the mind is useful for AI, or is that just again an anthropomorphic thing?
I think it is.
Well, GoFi people try and create the mind, and we, as neural network people, we try to recreate the brain.
Not exactly. I think everybody, not everybody. Okay, so I should never say ever, everybody, and so on. But I think neural network people assume that we're working on the system 1 level, right? Yeah. At a low level, and we would like the properties of system 2, which is mind, planning, and thinking, emerge. And there is a reason to believe it's possible because it's already happened once with this hardware and might happen with other hardware, right? So it doesn't have to be like GoFi people. The problem with GoFi people, they're trying to manually program that stuff, the system 2. And neural network people would like that thing to emerge, and that's kind of the main difference. It's just like a bitter lesson message that maybe, first of all, history shows that every time you hard code something in, like rule-based expert system, you will be outperformed later on by something which is more generic and kind of emerges. Yeah. You hard code whatever tricks of playing chess, you will be outperformed by massive search and so on and so forth. Same with AlphaGo, like self-playing. Bottom line, he says, it's not like we have to ignore the nature, but maybe, again, it's my translation of Rich's kind of bitter lesson, because I often have to argue with Joshua about inductive biases. I said, look, I have nothing against inductive biases, but you can have inductive bias in the form of rule-based expert system, that everything is encoded, and that's probably not gonna scale and not gonna work. Or you can have inductive bias of much higher abstract level of how the network scales, so the scaling algorithm is more efficient, and you end up with this brain rather than whale brain. So, like Rich's last paragraph was precisely, maybe we shouldn't be trying to focus on the end result of evolution, but on the process. It also can be called inductive bias. So there is also some patterns of how dynamical systems evolve so that the result will be good. But we don't have to encode the final result.
Yes, so you said so many really interesting things there. So first of all, I'm a huge fan of Joshua's GFlow Nets. We interviewed him. Absolutely amazing work. So you were talking about, isn't it interesting that you can start at the microscopic level and then you get these emergent functions like reasoning and planning and so on. And even that was a bit of an insight because it's a functionalist view of intelligence to say, it's a bit of, if you read Norvig, he talks about planning, he talks about reasoning, he talks about sensing. And actually, this is just our view of what is a very complex phenomenon. And I know you're a big fan of the blind men and the elephant, right? Which is to say that even though this is our view from different perspectives, it's all true, isn't it? But to some extent, the intelligence that emerges might just be beyond our cognitive horizon. Like, does it make sense to talk about reasoning, in your view?
Well, again, just like with that elephant, each person has a point.
Yes.
So, there is such thing as reasoning. You cannot say that it's totally like bogus or something. It might be, again, it's one perspective. Maybe it makes sense to just try to accumulate multiple perspectives instead of, so maybe we should be Bayesian instead of like trying to find a point estimate of AGI. Right? You can have a distribution of views.
Yeah.
And I'm a big fan of Eastern as opposed to Western views.
In anti-individualist.
As in viewing everything like that happens to you and to the world as well a large dynamical system. And yes, you are particle of that.
Yeah, so it's almost eschewing individual agency.
Yeah, so in a sense, it's yes and no, because, okay, so when people say there is no self, again, yes and no. There is self, but you also understand that it's like in the whole hierarchy of selves, like there is you and you're part of that larger dynamical system and so on and so on. So how to say, I'm not saying that, back to your question, that we shouldn't be looking into reasoning functionality as aspect of intelligence that we may want to develop. Yeah, so I don't see a problem with that.
Yeah, it might be a sufficient condition, but not a necessary condition.
Yeah, but basically intelligence or consciousness is probably much more than that, and definitely much more than reasoning. And well, here we go to another topics that I really like to talk about, but yeah, I don't want to keep everyone. I'm a big fan of Michael Levine, who you might...
Desperate to get him on the podcast. Yeah, because we've done lots of stuff on emergence recently, cellular automata, self-organization, and his take on it is absolutely fascinating. So yeah.
His talks are fascinating. I think I met him first at NeurIPS 2018. He gave the plenary talk, What Bodies Think About. The point was, guys, if you talk about intelligence as something that emerges in cellular networks, like neural networks, way before neurons appeared, other kind of more primitive types of cells had their bioelectric communication in their networks, and that determined what they remember and how they adapt. Yes. He focuses on morphogenesis, basically how the organism takes shape. And that relates to like embryonic development and so on and so forth. And the point is that if you look at that from the dynamical system point of view, and if you say that properties of the system like shape will emerge out of communication across those cells in certain way, that certain parameters of dynamical system. If you tweak that dynamics, and he was doing some simulations of where he wants to intervene, how he will intervene, like chemical interventions, just close open some ion channels. Cellular kind of system starts working in different way. And this is essentially his way of programming biological computers. Yeah. And the famous two-headed worms, three-headed worms,
Alex Moore Vincent.
and whatever stuff. And point was like, guys, like evolution found this solution or this solution. Wonderful. There are many others, and there may be better ones.
Yeah.
And look at the two-headed worm. It's not a fluke. It's a stable attractor that replicates.
Yeah. Yeah.
And evolution didn't create ever anything like that. We did, and it's stable. So it makes you think, what else can you do if you start reprogramming it, right? But yeah.
Two questions on that though. So I don't know whether you've seen that there's that example from Alex Moore Vincent with a gecko, and it's a CNN cellular automata. And now we're in this regime where we're transgressing rungs of the emergence ladder. So we're creating a high resolution cellular automata, and then even though it's only doing like local message passing, we get this emergent global phenomenon of a picture or a lizard or whatever. And now when you build systems like this, they can repair themselves, they can heal themselves, they have interesting dynamics. But as you're saying, we don't understand the macroscopic phenomenon, and we can only nudge it because it's unintelligible to us.
Right. Anyway, it's a whole kind of complex systems, science of complex system, like, yeah, and basically how do you program dynamical systems across multiple variants by local interventions so they will take the global properties that you would like.
Yes.
And avoid those. I mean, this relates to everything. It relates to the classical Moloch problem, right? What is Moloch problem? It's a complex dynamical system that with the current dynamics is getting into bad attractor, and most likely the way to get out is coordinated, simultaneous, distributed action. So on and so forth. Okay, we're not going to go there because I have to run, unfortunately, but I'd be happy to, I have some plans. I don't want to be late, but I'd happy to talk about that. And I mentioned Michael Levine also, not just because of two-headed worms.
I'm a huge fan.
But also because we talked about self. And we talked about, in a sense, hierarchy of selves and like what self means and how selves organize into larger selves. And we had an amazing discussion with him. I invited him to IBM research when I was there 3 years ago after his talk. I talked for 5 hours.
Yes.
It was great. And the idea basically, to some extent, was that he was also giving examples, not just of embryos, frogs, and those worms, but cancerous cells. If you look at them, like what's going on? When historically cells emerge like as independent selves, and everything around them is non-self. And therefore, self, to survive, tries to eat and use everything around, which means non-self. But when the cell becomes part of the network of the organism, then it changes behavior so that it kind of supports the well-being not just of that self, but the larger self it is part of now.
Yeah.
What is cancerous cell? It's a cell that forgot it's part of the community, reverted to its old state of being cell in the environment that is just environment. And it tries to eat it to survive.
Yeah.
And it's stupid in a sense because its objective function, survive and thrive, is right. It just applied at a wrong scale. Its spatial scale reduced and its temporal scale reduced too, because like if you kill the organism you live in, you'll die. So in order to understand that, you need to apply objective function to longer time scale.
Yes.
And then you get the hierarchy from cells, you get to organs, like to whatever particular organisms, to societies, to planet, to universe. And I say, Michael, so this is a good formulation of Buddhism. Basically, Buddhism means applying this function at the infinite time and space scale. Agreed. Yeah, so yeah, ever since I was saying, I'm gonna write a book about Buddhism for machine learning, and somehow it just didn't happen yet. But I should.
You should do. It was so nice to meet you.
Well, nice to meet you. I'll see you tomorrow. And I'm really sorry I have to run, but tomorrow, yeah.
Yeah, that was amazing. That was a really good interview.